Hello and welcome. I'm going to introduce you to some custom instruments for the helicycle. My name is Juan, and hopefully you're on my website looking at this video, and there it is in blue, www.wa6htp.com. If you're subscribing to my YouTube channel, you're probably wondering, why does he keep recording the same thing over and over again? What's wrong with this guy? It's because I keep making errors or factual mistakes, and I don't want to put out bad information. So let me get started. Just briefly, I spent 13 years working on and flying in large military and civilian aircraft. 5 years as a mechanic for United Airlines, 5 years as a NASA contractor, flying around in the back of a C-141. 2 years working on the Lockheed Skunk Works U-2, one of the main sensors on that airplane, and another year doing similar work for a joint U.S. Air Force and British Royal Air Force program. So I took all that experience and a burning desire to have my own turbine-powered single-place helicopter, and I decided I'm going to build a helicycle. And I found a kit which I thought was unused. I mean, it hadn't been touched. It looked like it was new, but it was on its third owner. So I bought that kit. I got it home, opened it up, and I realized it's an original packing. It kind of looked like it hadn't been touched, but start looking at the components, and a lot of them were screwed up. So the first two owners had gotten in over their head, finally realized that they weren't going to be able to finish the job, and sold it to the next guy. So finally, I was number 4. I threw out all the parts that had been goofed up by the previous 3 guys, ordered new stuff from the factory, and off I went. It took me 2 or 3 years working every evening and every weekend to finally get my helicopter ready to get certified, and it became N750 Golf, a Ferrari red helicycle, which I sold eventually, and it's now on its 8th owner and still flying. This is the instrument panel that I created for that helicopter. At the time, I was very, very proud of my work. Note the wonderful press-on labels that I made, and the super sexy colored arcs that I stuck on the glass in front of the instrument so I could try to make some sense of what they were telling me. So this was the instrument panel for 750 Golf. But as time went by, the rose came off the bloom, if that's how that goes. I started to realize, you know what? Most of these instruments suck. They're useless. I don't like them. These press-on labels are stupid. I'm embarrassed. I need to do something new. But it flew really great. So I flew my helicopter around for several years, but it slowly dawned on me that it's a fairly solitary hobby if you live where I do, because there was nobody within hours of where I live that had a helicycle. So when I went flying, I was all by myself. And after doing that for a while, it gets a little bit old. It was fun, but it wasn't as much fun as it should have been. And so eventually I thought, I think it's time to move on. So I ended up selling 750 Golf. I remember watching the owner driving around the corner of my cul-de-sac and the tail light of his trailer flickering out, and I thought, well, that's the end of that. Bye-bye. And then I fell into a state of deep postpartum depression. And I thought, what have I done? My true love is gone. My helicopter, what have I done? This is terrible. I need to build another one. I'm going to start out fresh with a clean slate, take everything I've learned through my experience working on the job and also building this helicopter, and I'm going to apply it to a brand new one straight from the factory. No used stuff coming from previous builders. I want a brand new one with no gummed up parts. So I ordered my kit with no instruments, no circuit breakers, no switches, no connectors, no wire, nothing to do with the electronics or the avionics or any of that stuff. Leave all of that off my kit. I don't want it. So that's what I did. I ordered it that way and set out to take all the lessons I learned building 750 Golf and apply them to my new helicopter. And this is the instrument panel. Actually, I don't think this was for, I did another one. It's a long story. I built two more after that. One of them was for a local fellow who wanted me to do all the work, but he never got his pilot's license. So that one is 99% complete, and it's just sitting in a hangar. If anybody wants to have a helicycle that has all the goodies I'm going to be discussing here, and it's all done, including the transponder, the ADS-B in and out Garmin transponder, and the VHF COM that you see there. I think this is the panel that went in that one. And then the one that I was building, same thing, another panel just like it. But halfway through that project, my eyesight went bad, and I thought, why am I doing this? I can't fly anymore. So I sold that one. Anyway, this is a panel using my stuff, so it really doesn't matter that much. What I did is I got some advice from Doug, the main helicycle test pilot, the gentleman that first talked B.J. Schramm into putting a turbine engine in the helicycle, and the test pilot who has tested 100 helicycles or more. And I asked Doug, I'm going to make custom instruments for the helicycle. Where do I want to put the green arcs, the yellow arcs, the red arcs, and the red lines? What is your advice based on all of your experience? And so I took his input, and that's what I used. The stuff that was coming out of the factory at that time was slightly different, but it was being generated by I think by a fellow who was a mechanical engineer, who was not a pilot and had never flown a helicopter. So I used the input from Doug to set up all of these instruments. I went to a company called UMA Instruments, and I said, I want you to build an entire set of instruments for the helicycle based on my requirements, and that's what they did. So I am the sole distributor, and I sell them, and I have UMA manufacture them. So let's go through this panel from top to bottom. So the upper left, that's a custom UMA airspeed indicator. Everything in that center strip, those are all UMA indicators. The VSI on the left is UMA. The dual tack in the upper right is made by Doug, and I think he's still selling them. And the altimeter, the sensitive non-TSO'd altimeter in the lower right, made in China, is sold by Aircraft Spruce. Any instrument that you see on this panel or on the one I'm going to show you, the lower panel, that has a red line or a red arc, has an alarm that comes out a pin on the rear connector. All of those alarms go to a module that I designed called the CAS logic board, CAS for Crew Alerting System. And based on what alarms are active, that CAS board will light one of those 7 red lights that you see in a row down there just above the VHF COM unit. And if any of those light, even momentarily, they will latch on the master warning annunciator at the very top of that panel. And that had 4 watts worth of lights inside it. It was extremely bright, and it was sunlight readable. And I did all this because in 750 Golf, I was flying along, having a great old time, flying along the Russian, not the Russian, but the what am I saying? Along the Monterey Bay shoreline. As I climbed out, my low rotor light came on, telling me my belts were slipping. I didn't notice that red light until I was back home reviewing the video I shot with the GoPro camera I had strapped on a headband on my head. And I thought, well, that's nice. What good is the red light if you don't notice it while you're flying? That's not going to work. I thought, hold on a second. All the big iron airplanes I've ever seen, 737s, 727s, DCAs, C-141s, U-2s, and a Canberra British bomber. All 6 of those planes that I've either worked on for years on end or flown in, all of them had a master warning annunciator at the top. If anything went sideways anywhere in the airplane, it would light that light. And that would get your attention even if you weren't scanning your instruments, because it would be almost in your line of sight at the very top of the panel. So even if you're looking at the windscreen trying to figure out where you're going and you're not paying attention to your instruments, that thing would cause you to go, whoop, something's happening. And then you would look down at all the little red lights to see which ones were lit. If one was lit, that would point you in the right direction. So let's suppose the engine light was lit. That would tell you either the EGT's in the red, the engine oil temperature is in the red, or the engine oil pressure is either too high or too low, both of which were red arcs, as you can see on the third one of those little ones in the middle there. That is engine oil pressure. So if any of those things happen, it would light the engine light. And even if something flickered on and off, let's say the pressure was being erratic for some reason, there were bubbles in the oil flow, even if that flickered off, the master warning would stay latched up until you reset it with a button on the cyclic grip. So even if you couldn't find what caused the problem, you knew something went sideways on you, and that would alert you either to do a precautionary landing or at least resume your instrument scan and pay a little more attention. So that's what I did. This is what it looks like. And now let's press on and look at the lower instrument panel. Here it is laying on its side. Now I'm going to flip it upright. On the left is the fuel quantity indicator. It has a red line, which I forgot to have silk screened onto the indicator. So as soon as somebody buys a set of instruments, I'll correct that flaw. There is an alert that would come out the back on a pin at a quarter tank or less. So at that point, you've completely drained the upper tank on your helicycle, and you're down to a quarter tank on the lower left-hand tank if things remain the same as they were. So we'll have a red arc there for that. The one on the right at the top is voltage, and here I have 2 red arcs. The volts can be either too low or too high. And down below is an ammeter. There's no alarms on that. And depending on what you have for a charging system, I modified my chip with a 55 amp automotive alternator. So this is a minus 60, 0, plus 60 amp indicator with no red lines on that one. I just keep track of the voltage. Down below are the switches that I recommend that you use. I would accept nothing else. These are Honeywell aerospace switches. They're in every airplane I've ever flown in or worked on. Every one of them had Honeywell switches. They have an elastomeric seal on the front that you can see. They have a matte finish, so sunlight doesn't glint off of these things and get in your eye. They're extremely high quality, very, very reliable, and like I say, every airplane I've ever worked on, the 737, the 727, the DC-8, Series 61, 62, and Series 63, they all had these same Honeywell switches. So I would suggest that you use those. And part numbers for all this stuff is on my website. Also, I should mention, I've started a discussion group that's on my website. So you can share information and ask questions and discuss anything related to anything I'm talking about. And I'll be furnishing all that stuff. So part numbers for things that I'm not selling, but I suggest you use, I will supply to you. And hopefully make your life a little easier. So here's a shot of part of the panel with the power turned on. Some of the instruments I've powered up, and I'm feeding an input into them, so they're not just sitting at zero. Again, there's Doug's dual tack up at the top. I recommend it. It's great. Notice that it has red lines for starter off and for start fuel off. So as the engine spins up, you have to turn those two things off in the right spot. And this makes it very useful. When the needle passes that first red line, let off of the electric starter, and the engine will continue to spool up on its own. When it gets up to the second red line, you no longer need that extra start fuel spraying into the engine. Let off of that, and that goes off. And then it will accelerate on its own up to the yellow arc, which is idle, which is 45,000 RPM. Which sounds pretty amazing if you're used to horizontally opposed four-banger, which idles at what, I don't know, 600 RPM. So what's going on down here? We've got some red lights on. Starting from left to right, the left one would go off if there was a chip detector, detected chips. I had one in the main rotor transmission and also in the tail rotor gearbox. Next would be the transmission. That one takes a little explaining. If transmission oil temperature was too high, that would set it off. And if fuel flow was too high, that would set it off. Why would you do that one? What's that got to do with the transmission? I'm glad you asked. The fuel flow is directly proportional to engine horsepower. And I explain that in more detail elsewhere. And I determined through research and looking at a video that B.J. Schramm did decades ago explaining the design of the main rotor transmission. And in that, he mentioned that there is a torque limit on the input shaft. If you exceed that, you're going to adversely affect the reliability and the longevity of that main rotor gearbox. And that turned out to be 90 horsepower. I then added another 10 for all the accessories, the tail rotor, the 55 amp automotive alternator, the scavenge pumps, the engine-driven fuel pump, engine-driven oil pump, all that stuff. I said all of that adds up to 10. So I don't want to exceed 100 horsepower into that shaft. And then pulling out the maintenance manual for the Solar turbine engine, there are graphs in there which convert fuel flow and ambient duct inlet temperature into horsepower. And so backing all that out, I came to 100 horsepower at normal atmospheric conditions at sea level was 15.9 gallons per hour. And so that's where the red line is on the fuel flow indicator, which isn't shown in this shot. So you'll have to trust me. So that would turn the transmission one on. Volts, I showed you the voltmeter, either too much or not enough. The alt light is just going to the idiot light output on the automotive alternator. Fuel would be low fuel quantity. Is there anything else that would cause fuel? I think that might have been it. And I've got a detail on how this CAS thing works right underneath this video in my menu system. So that's how all that stuff worked, and it worked just fine. Here's a little closer look. You can see that all of these little instruments, even though they're quite small, are very, very readable. They're all 270-degree sweep. They are expanded scale in many cases. Let's see if we have an example. Yeah, look at the middle one there. Instead of going from 0 to 300, it goes from 40 to 300. So that even expands the scale more. I don't care about, what is this one? Let's see. This is engine oil temperature. If the temperature is below 40, we shouldn't be flying. That's too low. You want to wait till it gets up in the green. So I don't care about anything below 40. So let's get rid of that. We'll stretch the scale out and make it even more readable. Notice how fat these bright white needles are. You can't miss them. So you can look at these with your peripheral vision and pretty easily tell if something's moving. Is it going up? Is it going down? Is it in the red or is it in the green? That's all we really want to know most of the time. And then here's a close shot of all those indicator lights that I told you about. Here is the fuel flow. That's the one I just mentioned. And you can see that the red arc stops at 15.9 gallons per hour. And again, that converts to 100 horsepower at standard atmospheric conditions at sea level. I found this to be really a useful gauge, and I always used it while lifting off and also while cruising. So as you pull a collective up, fuel flow at idle is around 6 gallons per hour. Notice this is expanded scale too. The standard UMA fuel flow goes from 0 to 20 gallons per hour. And I said, let's expand that out. Let's get rid of the 0 to 2. I don't want that, and I don't need anything over 18. So let's expand it. We'll go from 2 to 18, stretch that scale out, and get more resolution. And that's what we did. So as you're pulling up on the collective, you get up to about 10 gallons per hour. The helicopter is going to start to lean to one side or the other. It may start to yaw a little bit. The skids maybe are starting to wiggle around a little. So now pay attention. As you get up to 11 and 12 gallons per hour, you're almost ready to lift off. So now you want to get everything nulled out so that you're not, the helicopter's not torqued because there's yaw trying to twist it. It's not sliding sideways or tipping one way or the other. And you can judge all that by watching fuel flow. Worked like a champ. I loved it. And here's a comparison. I'm not sure that Westac is even still a viable company. I think it might have gone out of business. But let's compare these two EGT indicators. The Westac has a little teeny skinny needle, which is hard to see. It has a 90-degree sweep, which makes it almost useless compared to the UMA on the right. The lettering is very, very teeny and hard to see, whereas the UMA is bright and great big letters. The EGT from Westac had no arcs on it. That's all stuck on there with vinyl sticky back arcs that I bought from Aircraft Spruce. And remember, the red line on this one, per the maintenance manual for the engine, was 1180. And there it is. So anything over 1180, you're going to get a warning from this indicator, which is going to light the engine warning light and also lock up the master warning light up at the top. With the other one, not only isn't it going to do anything, where's 1180? Where is that? Where's 1100? Can you see where the red line would be on this thing? I have no idea. As far as I'm concerned, that instrument is totally useless. And I rest my case. Enough said. Here's the custom airspeed. I made 70 miles an hour straight down. So I tended to, on climb out especially, climb out at 70. Very easy to see that with your peripheral vision because the airspeed is in the upper left on my panel and it's pretty big. So as you're looking out the window, watching where you're going, as long as I could see that that needle was pointed straight down with my peripheral vision, I knew that I was climbing out at the proper entry speed for an auto rotation. So if something went sideways on me, I'm already at entry speed. I don't have to worry about it. If I was climbing out at 50, for example, that would make things a lot more risky, a lot more complicated. So that's the bottom of the green arc pretty much. Where does it start? I guess it goes to 60. But 70 still is, where I like to see that needle. I don't want it to go below 70 normally, unless I had a reason. And in the helicycle, you could cruise comfortably anywhere in that green arc. And I used to fly around at about 90 miles an hour. That was sort of my happy spot, and that worked great. Very smooth flying helicycle. Here's a shot of the CAS logic board. It's fairly simple, really. I designed this and built it. It's diode and an OR logic with those diodes up there, and they feed little latching relays, little sealed relays, those little black cubes. And the one on the far right, I made a misstatement. They're not latching. The 6 on the left are normal relays that are driven by the alarm conditions coming out the back of those instruments. The one on the far right is a latching relay. So once you feed power to the coil that latches it, it will illuminate that master warning light regardless of whether the signal's still there or whether it goes away. The only way to turn it off is apply some current to the unlatched coil inside that same little relay, and that was done by pushing a button on the cyclic grip. So that means that that master warning annunciator would stay lit until you turned it off. Here's a circuit board. It's a double-sided glass epoxy board. You can see the orange traces are on the back side and the green ones are on the front side. And all those little circles you see are called vias, and they transfer circuitry from one side to the other. And the 3 big holes, the 2 in the lower left and the 1 in the middle, those are mounting holes to mount that to whatever is handy. Up at the top is where the 37-pin connector went. So that's a quick run through of the instruments and how they work and why I think they're great. If you buy a set of instruments from me, I will supply you with my AutoCAD drawings, which will help you a little bit. I suggest that you use this free viewer, which is put out by Autodesk, the maker of AutoCAD. And it's a DWG True Viewer, or True View 2023 is the name of this thing. DWG is the native file format for AutoCAD drawings. And the fact that it says 2023 leads me to believe that it's a pretty modern piece of software that they put out, and it's free. And it does all the things that you need. You cannot create a drawing and you can't modify one, but you can zoom in and out, you can pan around, you can print whatever you want, and you can plot it. So if you've got a big plotter, you can plot everything out. One of the drawings that I would provide you is the upper instrument panel. And this is an example of if you wanted a full-size one, you'd have to plot it because it would take a C-size piece of paper. Most of the schematics I used to print on B-size paper, which is 11 by 17, and that works out pretty well. So this is a drawing of the panel that I've been showing you all this time. You could take this drawing, give it to your fabricator. He would enter it into his workflow. It would convert the AutoCAD drawing instructions to CNC machine instructions, which we get loaded into a CNC mill or a CNC router or an engraver. And you'd slap a piece of 6061 T6 90 thousandths sheet into the machine, clamp it down, hit the button. Pretty soon it would cough this panel out just like that. Now all you've got to do is paint it, fill in all of the lettering, and smooth off the excess, and it would look just like the panel that I've been showing you. And of course I have another drawing for the lower panel. Also, the schematics for the helicopter that I worked on. You would need to make changes as needed for whatever you're doing, but you can use these as a guide and a reference, and it will help you. So this is a detailed chunk of one of the two drawings I have for the upper panel. This little gray area, that's what we were just looking at, and here is sheet 1 of 2. That's the whole thing. So you could print that out on a B-size sheet of paper, 11 by 17, and you're able to see every tiny little detail. And using that viewer, you can zoom in and pan around and see everything just fine. On the screen right now, you can't see everything. There's text in there that's too small to see on the screen. Change of subjects now. So that's a sort of a taste of the instruments and the drawings that I have to offer. And now I want to introduce you to this little man with the red jacket on, who never turns around. He's always just strolling along with his back to us. And he is the symbol for Deutsch, the company that makes, one of many companies that make aerospace connectors and aerospace interconnect equipment. I like this little guy. I was first introduced to him when I was 19 years old, fresh out of high school. I had a friend who was a year or two older than me who went to work for the Lockheed Skunk Works. And he was working on a high security project. I had no idea what he did for years. Went to work every day, but he would come back and he would have a bunch of empty bags with this little mysterious man with his back to us. And he said, I use a lot of the stuff that comes out of these bags, and that's all I can tell you. And I thought, that is so neat. I like this guy. Who is he? What is this all about? So it wasn't until years later I found out he'd been working on a prototype of the Lockheed Skunk Works SR-71, which is the highest flying, fastest air-breathing jet aircraft that was ever built and that will ever be. It could fly at 2,100 miles an hour, Mach 3 plus, at altitudes, I think, up around 100,000 feet. It was an amazing airplane. And my friend Art did most of the wiring for the instrument panel on the prototype using Deutsch connectors that were manufactured by this little man. So now let's take a look at some. These are called bus modules. And there are two flavors that I'm going to show you, and they snap into these rails that you see on the left. If you look at the one on the bottom left, that can handle 5 of these little modules. And they would be labeled positions 1A, 1B, 2A, 2B, and 3A. And you see the 1 and the 2 up at the top and lines that span A and B directly below. So underneath 1 is A and B, left and right. Under 2, A and B for that section, and then one more would be 3A. So that particular rail will take 5 of these little bus modules. Now let's take a look and see what these are all about. There are 2 flavors, and the first one are 1 by 12 modules. There's one giant bus and 12 contact positions. So anything that is plugged into one of the 12 positions on this little module will be connected electrically to any other position. So if you plug 12 wires in, all 12 of them would have continuity between them. And so this is a little smidgen of sheet 1 of 2 from that drawing I just showed you. And this is instrument plus 13 volts. And so every instrument, of which there are quite a few, that are electrical, need plus 13, and they need a battery return. So all the plus 13s are all bussed together up here. So every instrument had a wire that went down here, and then a single wire, the one at the bottom there that says upper instrument panel, P4-19, that went off to the circuit breaker labeled instruments. The bottom one, those are ground returns, not only for the instruments, but for everything on the panel. They all have to get back to battery minus. And so we not only have all the instruments that were up on the top one, but you also have the transponder and the VHF COM. Now, these particular modules, the 1x12s, have number 20 contacts, which are rated at 7.5 amps maximum. And so as long as no single wire is drawing more than 7.5 amps, life is good. But on the ground return, for example, let's suppose the transponder was transmitting, and I was also talking on the radio along with the panel instruments, which are between them drawing less than an amp. But the VHF COM transmitter is going to draw some power, and so is the transponder if it's actively transmitting. And so that combined maximum would exceed 7.5, not for any individual contact, but in total. And so how do we get more than 7.5 amps out of that bus and back to the battery negative? You use 2 wires, just like I do on the bottom. So they'll split the load. So I've got 2 wires coming out of 2 separate contacts, each of which can handle up to 7.5 amps, and they both go back to eventually to the battery minus. So that's how you use those bus modules. Now on to the next one, which is even more interesting. This little guy is 5 isolated buses, each one with 4 inputs. So there are 4 contact positions on this little module, but there are 5 isolated buses, one from another. Each one has 4 contacts. So I've highlighted what I'm doing with the first bus, which is A, B, C, and D, or the contact reference designators. On the left, you can see that I'm using this for my chip detectors. So A and B are the main rotor gearbox chip detector and the tail rotor gearbox chip detector. C is chip detector input back to my CAS module, and D is a little stub that says N/C. What does that mean? That means no connection. So if it's not connected, why do I have a little wire hooked to it? It's to make things easier to see. If I just left those empty and you were wondering, well, is there more room on bus number 3, the one with contacts F, G, what do we got? E, F, G, and H, let's say. Do I have room for expansion? What am I doing there? That's lights or something. Suppose I want to add another light. Can I do it, or I have to start all over? To try and drill down and see if one of those is empty is, it's eye strain basically. But it's pretty easy to see, well, there's a wire coming out the right side of that little bus and it says NC. We're good to go. So that's why I did that. These use number 22 contacts, and they're only rated at 5 amps. So bear that in mind. Can't take as much current because there are 20 contacts in the same physical space as the other one that had number 20. Oh, I got that backwards. The other one has number 20 contacts rated at 7.5 amps. This has number 22 contacts rated at 5. takes different crimping tool for the two contacts, and the amperage maximum is different. And that's it. So that's an introduction to some of the things that I have to sell, the custom instruments, and I have a bunch of these two different types of these bus modules. So if you're interested, you can send me an email, or better yet, as I say, I'm starting a little discussion group that's going to be hosted on my website. I've got the thing loaded in there, but it's not working yet. But you can take a look. It's just like every other discussion group. So you will sign up, get yourself a password, and then you can post your questions or comments or suggestions, and other people can read your messages and respond to you, and I can jump in if I want and offer advice or whatever. So I think it'll be really handy once I understand how it works and get it going. So thank you. Look below this, the position where this is in my menu, and you'll see more information on the CAS board, and there's some other stuff down there, parts that I have for sale and tools that I no longer need. So all of that is in that part of the menu system. So thank you very much for watching this. If you're on YouTube, I promise I am not going to do this again, so you won't have to wonder why I erased this one and I'm back again. I'm done. That's it.